Okay, guys, we're back. We are now going on to number 28. And this section asks you to simplify each expression. And this is just adding and subtracting polynomials. Really, really simple. And here we go. So for number 28, we have 5n to the fourth plus 7n minus 5 plus, and they do parentheses here, they give it to you this way, 5n minus 4n to the fourth plus 4. Now because this is addition, we have nothing to worry about as far as negative signs and distributing the negative. So all you do is you gather like terms together. So this is an n to the fourth term, and this is another n to the fourth. 5 minus 4 is 1, so you have just n to the fourth. Then we have 7n over here and a 5n. We add those together. We're going to get 12n. And finally, we have a negative 5 and a positive 4. That's going to give me minus 1. That's it. 29. Here we have 2 plus 6b to the fourth plus 6b squared minus 5b to the fourth minus 8b to the third plus 3. Now this one becomes a little tricky because we have the minus sign, but I'll show you really quickly how to make it real easy. So we are going to change the minus sign to a plus, and we are just going to change the sign of everything in here. Just this guy, okay? And then we do it just like we did the previous one. So we have b to the fourth here, and we have b to the fourth. So 6 minus 5, that's 1, so that's just b to the fourth. Then we have a b to the third out there all by itself, so that's plus 8b to the third. Remember, you want to write these in descending order. Then we have a 6b squared all by its lonesome. And finally, we have a 2 minus 3, which is minus 1. And once again, you're done. Let's take a look at number 30. Here we have 2r squared plus 4r to the third minus 5. This one's a minus. 6r to the third minus 6r squared plus 5. Once again, the minus, we're going to make it a plus really quickly. This becomes a positive, and then everything in here just switches signs. So if it was negative, it became positive. If it was positive, it becomes negative. And now we just gather like terms. So we have a 4r to the third minus 6r to the third. That's negative 2r to the third. So those guys are gone. Then we have a 6r squared and a 2r squared. That's going to give me an 8r squared. And those guys are gone. And then I have a negative 5 minus 5, which is a negative 10. And we're done. Let's do 31. Oops, 31. 31, we have 2n plus 6 minus 3n squared minus 4n squared plus n to the fourth plus 8n. Again, it's a subtraction problem, so let's make it addition. This becomes a plus, that becomes a minus, that becomes a minus, that becomes a minus. And we bring all like terms together. So we have a negative 3n squared minus 4n squared. That is going to give me a negative 7n squared. Oh, wait, I think I forgot my n to the fourth. Let me do this one first. The negative n to the fourth that's out there all by its lonesome. And then we do the n squares, and these guys are gone. And then we have a 2n minus an 8n, that's going to give me minus 6n. So these guys are gone. And we have a 6 left. So let me put it all, smush it all together because it looks kind of weird. And there you go. That's number 31. Okay? All right. We're almost there, guys. Just hang on. Let's go ahead and do 32 and 33. Those are two multiplication of binomials, which everybody should know by now. We use FOIL for those. So remember, FOIL is first, outer, inner, last, right? So for 32, we have k plus 6 and 7k plus 4. So first is going to be this term times this term. That's 7k squared. Outer, that's the O, is going to be this term times this term. That's 4k. Inner is going to be this term times this term. That's going to be 42k. And last, let's see if I can find another color, is going to be 6 times 4, which is 24. So all you have left is make sure you combine these two together because they are like terms. So you are left with 7k squared plus 42k plus 24. And that's it. Let's take a look at 33. We have 5x minus 4, 6x minus 2. Again, we're going to FOIL. So first times first, that's going to give me 30x squared. Outer is going to be 5x times negative 2. That's negative 10x. Inner is going to be 6x times negative 4. That's negative 24x. And last is going to be negative 4 times negative 2, and that's positive 8. And once again, for number 33, you make sure that you combine those inner and outer terms. So this is going to be 30x squared minus 34x plus 8. All right. Now we're going to move to rational functions, which we just did. So hopefully that's still fresh in your mind. And it's multiplication and division only. So let's do number 34. You have x squared minus 9x plus 14 over 20 minus 10x. And this one is a division problem, x plus 10 over 10. So whenever you have a division problem, the first thing you want to do is make it a multiplication problem. That means change division to multiplication and flip the second fraction. So it becomes 10 over x plus 10. All right, and now I'm going to go ahead and factor up here. X and x. Factors of 14 that give me 9 are going to be 7 and 2, and they're both negative. And down here I'm going to pull out a 10, and I'm going to be left with 2 minus x. Okay, and now I'm ready to cancel. So let's see, this 10 goes away with that 10. This x plus 10 doesn't have anything, so it's unfortunately going to have to stay. Now what you do need to see, and this x minus 7 also has nobody to cancel with. But these two guys here are very, very similar. They're off by a negative 1. Here you have a negative 2, here you have a positive 2. Here you have a positive x, here you have a negative x. So what I'm going to do is I'm going to pull out the negative 1, and I taught you this already, guys. It's a little trick we do, and that'll change the signs in here and allow me to cancel those guys. And I'll be left with a negative 1 in that denominator. So here I'm left in the numerator with x minus 7 over negative 1 times x plus 10. Now you might see this a little different. You might see the answer, distributed, and it might look like negative x minus 10. It might look like they simplify it by dividing every term by negative 1, or it might look like that. Chances are you will spot it from the multiple choice, but this is fine, this is fine. Those are okay as far as solutions. Okay? All right, let's try number 35. So for 35, we've got 4 over x squared plus 12x plus 27 divided by 1 over x plus 9. Okay, so once again, the first thing you do with the division is make it multiplication. So we did that, we flipped it, and now we're going to factor here. So factors of 27 that give us 12 are 9 and 3 plus and plus. This one's really easy. All you're canceling out is the x plus 9, and that's it. You've got nothing left to cancel, so in the numerator you're left with a 4, and in the denominator an x plus 3 times 1, which is just x plus 3. Okay? 36. 36, we have v minus 9 over v plus 4. This one is a multiplication one, so we don't have to flip it. All right, so we're going to factor this guy. We've got v and v. Factors of 40 are going to be 10 and 4. That add up to 14. And v and v, we're going to have 10 and 1 add up to 11. Okay? We're ready to cancel, so we have the b plus 4, b plus 4, b plus 10, b plus 10, and you'll be left in number 36 with v minus 9 over v plus 1. Okay? Number 37. We have 1 over x minus 7 times 9x minus 63 over 2. Again, this one's multiplication, so we do not have to flip anything. We're going to pull out a 9, and that'll be x minus 7. And here, when we cancel, the x minus 7's go away, and you're left with 9 over 2. Believe it or not, guys, we've only got 3 more problems. Oh my goodness, I know. This is so exciting. Let's go ahead and take a look at 38, 39, and 40. These require you to use a calculator. So whichever calculator you use, make sure you know how to use the log function. All right? So it is giving this an exponential, and it wants, let me show you the actual question. It says solve each equation, round your answer to the nearest 10,000. So in order to do that, we're going to go ahead and change this to a log. We're going to change from an exponential to a log, and if you remember, this is the base, this is the exponent, and that's the argument. So changing it to a log would look like log of base 16 of 99. So log base 16 of 99 equals So I'm looking for that little n there, the exponent. Okay? Now, if you look at it this way, our calculators, they don't have a log base 10. So I taught you guys how to use the change of base. And that's really easy. All you do is that log base 16 of 99 is going to equal the log base 10 of 99 over the log of 16. And that is super easy to do on your calculator. You just type 99, press log, and then divide 16, press log, and don't forget to press the equal sign. And that's going to give you approximately 1.6573. I believe it asked for 10 thousandths place. You'll be able to figure it out when you see the multiple choice answers. Okay, so that was number 38. Number 39, all of these are done the same way. 6 to the x equals 92. Change that back to a log. That's log base 6 of 92. And we use the change of base, so this is the log of 92 over the log of 6. And off we go. 92. The log of 92 divided by the log of 6. And don't forget to press the equal. So that is approximately, right? It's not going to be exact. 2.5237. I rounded that one. And then finally, number 40, 10 to the p equals 28. Again, this is going to be log base 10 of 28 equals p. Now this one's interesting because we do have a log base 10, and that's this guy. So you don't really need to use the change of base like we did for these. You could just type in 28 and press log, and that will give you the correct answer, which is 1.4472. But let's say you forgot that because you're taking the test and you've done so many of these already. All you do is log of 28 over log of 10. You're still going to get the same answer. That's going to be the log of 28 divided by the log of 10. And that's still going to give you that 1.4472. Wow, guys, we did it. We made it. Be on the lookout for the next video on the graphing portion, and you'll be ready after that. See you next time.